most of the time you should pick the denominator. The derivative of e to the 3x is e to the 3x times 3 because of the chain rule. And then that subtract 1, the derivative of that goes away. So the derivative of the denominator is the numerator, give or take a factor. So e to the 3x minus 1. So when in doubt, just use the denominator. Try it. If it doesn't work, try something else. So the derivative of that would be 3e to the 3x, chain rule, and then dx. So I don't want 3e to the 3x. I want 1e to the 3x. So I have 1/3 du. Okay. So what I'm going to do is reassign a few things. And this one's going to get a little bit tricky. So we're going to have the integral from, okay, we're going to have to change some numbers here, and we'll deal with that in a second. But so far we have u and 1/3 du. Okay, so everything here in the what would have been an indefinite integral is accounted for. U is in the denominator, 1/3 du is e to the 3x dx. It's all good. Now, this number is what I get when I plug a 1 in here. It's going to get tricky. So I'm going to plug a 1 in here, and I get e to the 3 times 1. That's e to the 3, and then minus 1. So it's, as gross as it is truly e to the 3rd and then minus 1. Let me get out of the way so you can see. And then when I plug a 3 in here, I get e to the 9 minus 1. So it is, well, e to the 9 and then minus 1. And that's it. Okay, I mean, that's not it. We're not done with the problem. But we can now integrate this. So let's integrate this. We have 1/3. And at this point, we have the structure where the denominator is to the first power. So we will do that. Okay, no need for a plus c. This is a definite integral. And it goes from these two ridiculous things, e to the 3rd minus 1 to e to the 9th minus 1, which of course would be bigger because of e to the 9th. And we're going to plug e to the 9th minus 1 in, e to the 3rd minus 1 in. We're going to subtract, and it's going to be really gross looking. So we're going to have 1/3. And let's see, 1/3 natural log of e to the 9th minus 1. Okay, we have some absolute value going on here, but I don't need the absolute value. I don't know why I'm waving my hands back and forth like this. I don't need the absolute value because e to the 9th is like ridiculously positive, and then you subtract 1, you're good. So e to the 9th minus 1. We don't run the risk of that being negative. And then minus 1/3 natural log of, okay, e to the 3rd is also quite positive. Subtracting 1 doesn't affect its positivity. There we go. So this is a very valid answer. However, we are going to continue working on this one. We're going to continue working on this one because this would be an excellent multiple choice question. And multiple choice questions are notorious for, hey, I got the answer, but I don't see it, but you still did it right. So let's keep going. I'm going to just beat the mess out of this thing, and we're going to do it all kinds of ways. First of all, valid answer. Second of all, e to the 9th minus 1 minus natural log of e to the 3rd minus 1. Also a valid answer. We're factoring a 1/3 out. All right, let's keep going with this. So valid, valid. Let's keep going with the validity here. Because we're subtracting logs that have the same base, they're both natural logs, so the base is e down here. Because we're subtracting logs, we can divide and create one log. So let me stand in the way so you can't see what I'm writing. Natural log of, okay, here's what's about to happen. We are going to have e to the 9th minus 1 over e to the 3rd minus 1. So e to the 9 minus 1 over e to the 3rd minus 1. And that's another way of doing it. All right, still valid. Could we? Could we? We could. We totally could. Should we? We should. Let's keep going. I'm going to do something that may or may not be obvious, but well, this part's slightly obviouser than the other thing I'm going to do. This 1/3 can become an exponent, which makes it the natural log. And again, all valid, 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 valid. E to the 9 minus 1, e to the 3rd minus 1, which is to the 1/3, which means it's the cube root of that stuff. So it's the natural log of the cube root of e to the 9 minus 1. Oh my goodness, make it stop, make it stop. Okay, there's one more I'm just dying to do. Not literally dying, I don't want to die. I'd rather do math. But there is this really obscure, and it's worth talking about, obscure way of factoring the difference of perfect cubes. And I have time, I keep looking at the clock. I have an appointment. I'm about to go to the dentist. Like, you don't care, but I'm telling you anyway, but I have time to do this. And even if I didn't have time to do this, I'm going to do this because I'm having fun, doggone it. This is an obscure way of factoring the difference of cubes. And these are perfect cubes. This is obviously e to the third minus 1. And this is e to the third cubed minus 1. It's beautiful. So you may or may not have seen this before. It is, again, very obscure way of factoring. But if I have the difference of cubes, then it breaks up like this. So following that same idea, if I had e to the third minus 1, then a would be e and b would be 1. So I would have e minus 1, and then e squared plus e times 1 plus 1 squared. Okay, so there's that. And then if I had e to the ninth minus 1, this is kind of side, it's going to get me where I'm going with this one. I would have e, let's see, a cubed is really e to the ninth, which would make it e cubed. I'm just having fun at this point. So this was e cubed minus 1, and this would be e cubed squared plus e cubed times 1 plus 1, okay? And without doing too much with this one right here, I'm going to factor that numerator the way we just saw it. So here we go. And let's do it. Well, looks like I'm writing limit. I'm not. I hear a siren in the distance. Apparently someone divided by 0. Natural log of the cube root of some stuff that's about to happen. I'm going to keep that denominator as e cubed minus 1, even though I do know how to factor it. Trust me, I know where this is going. I've got to go get my teeth cleaned. So e cubed minus 1. The numerator is e to the ninth minus 1, which is this. So e to the third minus 1. Oh, there it is. E to the sixth plus e squared plus 1. E to the third, sorry. Has math ever been this fun? Seldom. Okay, you see it, don't you? Don't panic about this, by the way. If you're like, I don't remember that. No one ever showed me. No, you're good. So the most simplified I know how to get it is this right here. Natural log, again, it looks like a limit. Natural log of the cube root of e to the sixth plus e cubed plus 1. Man, that was beautiful, wasn't it? I like it too.